As it is now, Briskillanya is very similar to Earth. To become so similar to Earth, it would have had to evolve in a similar way, and it did. In this video, I will go over the history of Briskillanya from before its formation to just before the advent of civilization. In the beginning of this episode, I won't focus exclusively on Briskillanya, but also its fellow intermurobliscian planets. As Briskillanya's path diverges from that of its neighbors, I'll start to focus on it more. All times are given in Earth years. The Miroblisc system was formed from the collapse of a molecular cloud around 4.51 billion years ago, and Briskillanya formed soon after. Occurring in the warm, volatile, poor inner parts of the system, the formation of the planet was fairly average, just as incredibly violent and chaotic as the formation of any planet. The high presence of iron in the newborn planet's orbital region caused it to gain a decent quantity of iron and other metals, giving the planet its high density. Fairly soon after, Briskillanya developed a Trojan companion, a planet slightly smaller than Mercury that will be given the name Aronevi. Briskillanya was initially spared from the brunt of Hyblack's temporary intrusion into the inner Miroblisc system, but the giant planet's presence disturbed the orbit of Briskillanya's Trojan, eventually causing Aronevi to collide with Briskillanya to form Haristi and Letrobriskin. Both moons started out much closer to Briskillanya before receding from the planet. Haristi would go on to be very important for Briskillanya by stabilizing the planet's axial tilt, slowing its rotation, creating tides, and contributing to the formation of plate tectonics. A similar, relatively concurrent event caused the formation of Satyria's lone moon Weenlace. After most of the chaos of planetary formation had subsided, Hubrae formed in a Briskillanya crossing orbit from leftover debris. This orbit was dynamic, as Briskillanya and Aronevi both heavily gravitationally influenced the then asteroid's movement. Around 100 million years later, or about 4.375 billion years ago, the outward migration of Jinpra and Hyblack's influence on the Yad belt caused many volatile rich bodies from the then larger Yatas and Tazalin belts to be scattered, a process that sent many of these objects to the inner parts of the system, where they eventually collided with the now solidified inner planets. These bodies brought many volatiles: methane, carbon dioxide, oxygen, nitrogen, ammonia, and most plentifully and importantly, water. Concurrently, volatiles from within Briskillanya, Aronevi, and Sierret began erupting from the planet's interiors, starting the formations of their oceans and second atmospheres. Blazon and Soteria never were able to have liquid water on their surfaces due to the former's airlessness and proximity to Miroblisc, and the latter's slow rotation inhibiting its ability to have a magnetic field. Both of these planets still have frozen water on their surfaces, Blazon having it in some shaded parts of polar craters that never see the sun, and Soteria having it in its ice caps. Meanwhile, the other three intermurobliscian planets, Briskillanya, Aronevi, and Sierret, were able to have surface water, though Sierret only had comparably small lakes and streams that eventually went away after the small planet's interior cooled, causing its magnetic field to die, causing most of its atmosphere to escape into space. Most of the water froze and would later contribute to Sierret's dynamic ice caps, and some joined the atmosphere in escaping to space. Briskillanya and Aronevi, however, due to their robust magnetic fields and optimal locations, were able to develop nearly global oceans. These volatiles also contributed to the second atmospheres of Briskillanya, Aronevi, Soteria, and Sierret. Briskillanya and Aronevi, now not only the sole ocean worlds in the inner Miroblisc system, but the sole geologically active worlds in that region, started to develop additional dry land due to this geological activity, allowing for plate tectonics. Initially, both planets just had some scattered islands, before small continents started to coalesce. The same processes led to the formation of hydrothermal vents, where life would eventually appear on the bottom of both planets' oceans. Around the same time, Hubrae's orbit increasingly began to resemble Briskillanya's, because numerous flybys of the planet had caused Hubrae to slow down in relation to Briskillanya. Eventually, during one fateful flyby, the combined gravitational influences of Briskillanya, Aronevi, and Haristi caused Hubrae to be captured by Briskillanya, making it the third Briskillanyan moon. After about 3.4 billion years ago, something remarkable happened at the bottom of Briskillanya's single gigantic ocean. Near a hydrothermal vent, some complex organic molecule made a crude copy of itself, using the soup of smaller organic molecules provided by the vent. Some basic phospholipids shaped themselves into a primitive version of a cellular membrane. Eventually, these two forms of protolife combine to make small, membrane-bound blobs that contain basic cellular machinery and DNA that gave instructions on how to make proteins and copies of the blobs. In other words, the first prokaryotic cells, Briskillanya's first life. Initially, since sexual reproduction, which enables organisms to share genetic material that could include beneficial mutations, hadn't been created yet, these organisms evolved at a very slow pace. planets. However, life managed to spread throughout the Briskillanya mega-ocean. The prokaryotes still managed to diversify as things like flagella and cilia came into being. Some microbes moved onto the growing continents. In addition, viruses appeared. Most importantly, some of the simple organisms became capable of photosynthesis. Over the course of nearly 1 billion years, they filled Briskillanya's atmosphere with oxygen, making it breathable to modern organisms, but also causing a mass extinction like Earth's Great Oxygenation Event, as oxygen was toxic to many organisms in the ancient Briskillanyan oceans. Only particularly oxygen-resistant organisms were left behind. The influx of oxygen also reacted with the dissolved iron then in the oceans, turning them red, and the new reduction of greenhouse gases caused the whole planet to freeze over about 50 million years later. After this glacial period ended due to greenhouse gases from volcanoes returning to the atmosphere, the first eukaryotes submerged in the still red ocean after some prokaryotes developed nuclei and engulfed some energy-producing prokaryotes about 2.0 billion years ago. Later, as the ocean started to turn blue again, some of the early eukaryotes did the same to photosynthetic prokaryotes. Briskillanya now had several major continents at this time. About the same time, life appeared on Aronevi. It formed through about the same mechanism that Briskillanyan life appeared through, and Aronevi photosynthesis evolved afterward. A little over 1.5 billion years ago, these new Briskillanyan eukaryotes started to team up with one another in mutually beneficial situations. In other words, basic multicellularity had appeared. Most of these early multicellular organisms were fungal in nature, and some protoplants evolved afterwards. Both started to move onto the comparably new continents. 500 million years ago, soon after the first true plants and animals appeared, Briskillanyan life rapidly started diversifying, at least in part thanks to the emergence of sexual reproduction. The new animals included worms, arthropods, and early vertebrates, all fish-like at this time. The ozone layer formed, and plants, now having vascular variants, started to conquer the land in full force, forming great forests. The plants, having become flowering a lot more early than they did on Earth, were followed by invertebrates. Though interrupted by a few great glaciations, the animals were poised to conquer Briskillanya. About 300 million years ago, on the coast of what is now inland and Yanton, vertebrates moved onto land for the first time. At first, they were just legged fish that eventually gained lungs, but amphibians appeared after. With Briskillanya's land now being visibly green from space, the amount of atmospheric oxygen had increased again, allowing land animals to grow larger, and many of them did. For about 200 mega-annums, these megafauna will rule much of Briskillanya. Initially, these just included arthropods and amphibians, but as other categories of animal appeared, like the reptiles, birds, and mammals, they had very large variants as well. However, the amount of oxygen in the atmosphere began to drop as vast amounts of herbivorous creatures lowered the amount of plant life. By 150 million years ago, most of the land that comprises the modern land on Briskillanya had become dry land, except some low-lying areas and some geologically young islands like the Lesser Russellians, and the general relative positions of the modern continents were coming into being. The Indian and Hilara were still stuck the western Aberdeen, making the Counjier Ocean nearly inland. Much of modern-day Ainus was underwater. What's now Aizartach in the northern half of the plateau that bears its name was upside down in its own body of land. Solhant was far more remote, Pydene was further east and west, and eastern Aberdeen was significantly further south, but everything was falling into place. The climates were rather different. The whole planet was a bit warmer. The central desert was significantly bigger, that would eventually disappear and reappear. The Pydene Desert was significantly smaller. The Aizartach Plateau was yet to form, and wetlands comprised a much greater portion of the planet than they do now. As the amount of oxygen in the atmosphere declined, very large animals were no longer viable and started dying out about 100 million years ago, leaving behind smaller animals. In addition, about 40 million years ago, due to the natural variations of Briskillanya's orbit, the planet's temperature started to drop, causing another ice age. This caused the animals with natural protection against the cold, primarily birds and especially mammals, to start doing well compared to the poikilothermic species of the planet, allowing many new types of mammals to evolve during this time, including the first mammalian carnivores in the wild, and mammalian megafauna returned to Briskillanya. 20 million years ago, the map of Briskillanya was familiar, despite the Ice Age bringing lower sea levels. The three smaller continents had fallen to their modern positions, and the plates then combining to form an Aberkinian supercontinent were in the right place and touching one another. Aizartach's plate had recently and relatively quickly slammed into northern Aberdeen, creating the Aizartach Plateau in the process. The Lesser Russellian Islands formed from volcanic activity as the Russellian plate moved into the location of its namesake bay. As the Ice Age began to end due to orbital variations, approximately 3 million years ago, cold-blooded animals grew back to prominence. Mammals had to adjust, and there was a temporary decrease in the amount of mammals on the planet. The glaciers started retreating, creating the fjords of southern Fjords. This warming trend continued, causing some coastlines to recede. The central parts of Abercrombie started to become warm grasslands, where early primates thrived. In the savannas of the modern-day eastern central desert, far eastern Angus, and far western Laval, new species of primates started appearing. Eventually, modern Briskillanya humans appeared in the region about 300,000 years ago. At this time, the planet started to return to a more moderate climate, and it cooled to its current temperature. Approximately 100,000 years ago, the rivers supplying central Abercrombie with water dried up, and rainfall stopped hitting the region due to changing sea currents, creating the modern central desert. This drove humans to leave the region and populate the surrounding ones. The warm climates of southwestern Laval, Agnes, southern Wemvar, and northern Aachen were palatable to these early people, and these regions got populated first. By 90 millennia ago, humans had moved into southern Aachen, northwestern Fjords, eastern Laval, a great many settled in the fertile Raetla, northwest Laval, central Wemvar, Verokachien Tashai, and southern Reveta. With the exception of eastern Laval, these places were cooler in climate, but the ingenuity of these hairless apes mitigated that problem. Next, the humans moved into Strokopervanach, more of Laval, and some more parts of Fiora, but the Fioran mountains kept them from moving further south, and those who went around the mountains usually ended up returning because the cold climate and rocky composition in the land made it suboptimal for habitation. Around the same time, which was 80,000 years ago, the humans moved into places now called northern Wemvar, northern Reveta, and northeastern Laval. Next, about 50,000 years ago, humans moved into eastern Trebina and Vinkla. Then, 30,000 years ago, they moved into Pensalista and Rakan, which were previously avoided because of the mountainous terrain and cold climate. After a break in human expansion, the Proto-Strokopervanachians figured out how to make boats, originally to fish. However, some fisher must have accidentally made the 10-ish day journey to Halara 20,000 years ago. Others followed, and the eastern coast of Halara, followed by the northern coast, were colonized by humans. Then, 10 millennia in the past, Proto-Revetans used boats to sail to the Briskillanya Islands, as the early Halarans moved inland and took the whole north and west coasts of the continent, where the early roots of Senili took hold. Later, about 7,000 years ago, these early Halaran peoples would sweep the southern portion of the Hantian continent in 2 waves after sailing across the Anion Sea. Around the same time, several peoples on the Abercanian Enian coast would sail to the western coast of Haideen, the last continent to see habitation. In the next millennia, humans would spread out through the rest of Hantia and more of Haideen. Around the same time, approximately 5,000 years ago, people in the Aini River Valley invented large-scale agriculture. This made enough food to create surpluses, which prompted trade. Early civilization had begun. That's it for this episode. This is the first episode that is recounting chronology, so I may be a bit awkward with that, but future ones also will. Episode 10 will be a shorter one about the climates of various parts of Briskillanya, if you're interested. Major thanks go to both Puppet Head for making the song that you hear playing right now, titled Briskillanya, and to Algol, whose History of the Earth video was very helpful to me when making this video. Puppet Head's channel and Algol's video will both be linked to in the description. Goodbye.